Welcome back. Why do we just learn all of this? Well, because now we know a critical part in being a JavaScript programmer. We want to write code in a way that helps the compiler make optimizations. We don't want to work against it and make things slow. Throughout the rest of the course, we're going to learn different ways to write efficient code, but I want to give you some basic things to watch out for when working with JavaScript engine. Now, keep in mind that most of these things I'm going to show you will seem like things you don't really use or see that much anymore. And that's because most developers don't use them since they can be bad for optimizations. But it never hurts to know what they are. It doesn't mean that you should never use them, but that the use cases for them are very rare. So here's the list. In order to help the JavaScript engine, we want to be really careful with these on the left. Functions that call literally the eval function, which comes with JavaScript, can be very problematic. Arguments, which we're going to talk about when we get into functions of this course, something that comes with every function. There are many ways that we can use this keyword by JavaScript, but there are many ways that makes compilers unoptimizable. So we have to be really careful with using arguments. And I'll show you later on how we can use parameter destructuring to avoid using arguments. Foreign loop, for example, when looping over objects, can also be problematic sometimes. So I like to use object.keys and iterate over the object keys that way. The with statement, which once again you don't see very often in the wild anymore, is another problematic one. And also the delete keyword in JavaScript can be problematic. Now, I'll leave resources for you to read up on them if you really want to get into the weeds. But there's two main things I want to talk about here that are the main reasons that these things in JavaScript can make our code less optimized. Let's have a look. The first thing I want to talk about is something called inline caching. And inline caching we can demonstrate this way. Let's say we have a function, and this function will say find user that takes in the user parameter. And this function will just return a template string. We'll say found, let's say user.firstname, then last name. And here we can just create an object, call it user data, that will have the first name, say Johnson, and last name, say Junior. Now, all we do here is say find user and give it the user data object. Now, inline caching does something really interesting. Due to inline caching done by the compiler, code that executes the same method repeatedly, that is, let's say the find user method or function was being called multiple times, well, the compiler can optimize this so that whenever it's looking for the user data, which has first name and last name, it can use something called inline caching, where instead of looking up this object every time, finding the key that is first name and last name, and then their values, it will cache or inline cache so that find user just becomes this piece of text. So if we call find user over and over, we would just replace that with found Johnson Jr. Because at the end of the day, that's all that the function is doing. The other one that is really important for optimizing compiler code is something called hidden classes. And a lot of the gotchas that I showed you previously, that is this one over here, such as the delete keyword, really affects this hidden classes when it comes to compilers. Let's have a look. If I had a function, let's call it animal, that receives x and y parameters, and we'll use the this keyword for now. We're going to learn more about that soon in this course, don't worry. But let's say we just have this animal with X and Y properties. And now we create a new object. Let's say const object1 is going to be a new animal that takes in 1 and 2 as the properties. Doesn't really mean much, but there's our first object. And then our second object will do the same thing, but this time with different parameters, 3 and 4. Now, a compiler is going to take a look at this and say, all right, we have an animal that we're creating here, and we're assigning it to object 1 and object 2. But if I go ahead and add object 1.a to equal, let's say, 30, and then object 1.b to equal 100, and I'll do the same thing for the object 2, except that this time around for object 2, I'm going to create it in different order. So that is, I add the B property and then the A property to object 2. Hopefully that's not too confusing. That code is actually going to make the compiler run slower or de-optimize the code. And that is something called hidden classes. You want to try and instantiate your object properties in the same order so that hidden classes, which is what the compiler uses underneath the hood to say, oh, this animal class, this object 1 and object 2 objects have the same hidden class. That is, they have the same properties. But as soon as you start introducing things in different orders, it's going to get confused and say, they don't have a shared hidden class. They're two separate things. And internally, that's actually going to slow things down. So one thing you want to do in a situation like this is to assign all properties of an object in its constructor over here. So that is to add the A and B property in here so that you avoid this issue. Or making sure that we add things in the same order. And that's why there's this issue of delete keyword as well. If I delete the property here of the object, well, again, I changed the hidden classes so that they don't match up anymore. Now, when it comes to optimizing the compiler, there's small little gotchas like that you don't really have to worry too much about it. The key takeaway from here is that we should write code that is predictable, not only for humans, but also for machines. The more predictable your code is, the better it will be because it'll have no surprises. And throughout the course, we're going to learn these practices that will help us write optimized code that is predictable and that doesn't confuse the compiler. I'm not going to mention every single time that we're doing an optimization for the compiler. We're just going to assume that these best practices, when incorporated, like I'm going to show you throughout the course, it's going to help us write fast, efficient code. I'll leave resources for you here if you want to learn a little bit more about this topic and really get into understanding what this hidden classes is. It isn't something that you need to worry about too much. But for now, I'll see you in the next video.